All right, I learned a new thing this morning. What did I learn? Well, I'm going to show you what I learned. What I learned, thanks to Chris Herman, is how we can actually read and write from the desktop and not have to do that weird directory or save to a memory stick. All right, so here was Chris's technique. Make a very quick program here. I'm going to want to read, so I want an input stream, F stream. I'll call it read. F stream. Call it read. All right, and then here was Chris's technique. You create a file and you save it on the desktop. So I've created a file called input.txt. You right-click on it, and you go to Properties, and that will give you the path. So here is the path. And you copy that. And you come back to here, and you put that in, and then I called it input.txt. IOS in. That's what I had tried in the past, and that never worked. And you can see it's got red underlining stuff, doesn't like it. What Chris did is he came through here and he reversed all of these slashes. Like so. Don't know why he thought of that, but he did. Kind of a strange idea. All right, so if I come down here to my void main now, I can do, I need a variable, I need to include string because I got a string variable. Include string. String. Word, I guess. I can now read Word and then CL Word. And so all this program should do, my file contains one word, it should read that one word, save it to the variable called word, and then it should print that one word to the screen. Oops. Typing issues this morning. Let's see if it worked. So I read the word, thank you, Chris. I made it one word, so if I put spaces in between, I would have had to really read three things. All right. So there's a way that you can save your file on the desktop and read it. At the same time, you could create an OF stream and use the exact same path and write to a file. The only problem is this path is different for different computers. So if you write this on this computer and then you go to the lab and try to run the same thing, this path on the computers in the lab is a different path. So if you're doing it in the lab and then transferring it to your personal computer, again, they will have different paths. So you'll have to change the path for every different computer that you use. But that's not that big a penalty to be able to save things on the desktop and have them very, very easy to find. So the path might be the same, correct. I think in the lab, I think every computer has the same path in the lab. But if you're working in S123 in that lab and then you move to S122, the computers in that lab will have a different path. So you'll just have to save your file, find the path, change your code here slightly. Okay. All right, so that's kind of a handy thing. And it strikes me as very, very weird because I have never seen file directories written that way before with the slash going in that direction. File directories, the slash always goes the other way. Never seen it that way before, but it works. Well, there we go. Helpful little thing. All right. Anybody have questions? Questions on anything? Yeah, you reverse the slashes and it works. I don't know why, it just does.
I tried that because when you're navigating like on a terminal, you always use those types of slashes.
Okay.
So it was like, it was weird to me to see them reverse.
I see. Yeah.
So I was like, I don't know why it worked.
It works. We're happy. That's good.
Yeah, that's exactly what
Okay.
it is. In the console, it's working the other way. With different
In the console, so here in the MS-DOS prompt, which nobody uses anymore, it goes the other way?
stuff. It's a whole other function.
Okay.
I wonder if it's because if the slashes go the other way, like if you go to, you want to find E drive, it will read E drive and then read to right. If you put the slashes, it might read to right and left.
I don't know. It works. We're happy. We'll live with it. We'll use it every day. Other questions? Comments? Concerns?
Have you tried this for writing through a file as well?
Yes, we did try it in the lab and it worked. Yep. Just make sure you have the same path, slightly different file name, probably output.txt, and of course change this to out. And yes, it does work. We tried it. Other questions? All right, so I passed out a new sheet. You should have gotten a new sheet here. The front stuff, we've pretty much done all the stuff on the front. The front was, we learned how to first create functions, what a function prototype is, what the function header is, all that sort of stuff. So the front we've done. So we're ready to go to the back. We're going to write some functions. So it says, write a function to print the header for a lab. All right, I'm not going to write the whole function, but how would you do that? So you want a function that prints the header. What kind of function would that be? It would be void because it's just printing. It's not going to return anything. All right, so we would write void. What do we want to name it? Header. And what kind of variables are going to go into the header? None. I put a semicolon there. What's that called again? That's called the function prototype. And when we come down here, and we actually write the function, so we need void header. No semicolon here, but rather a curly bracket. I'm not going to write the whole header that you would write on your code, but we would have cout, a bunch of asterisks, right? Cout, name, etc., etc. You would keep putting all your couts, all the couts that you usually use for your header, you would put them in this function. Okay. Don't want this stuff anymore. How would I run that? How would I get in my main? How would I get my program to jump down to that function, run that, print my header for me the way I want it to? Do what? I just do a function call. The function call would be header. And I need the parentheses. Although it doesn't send anything, I still need it. All right, so there's how you write a function that simply prints something. And we did that before. We wrote a function before that printed directions for a program. Same thing, it's a void function. Nothing goes in, nothing comes out. All it does is print. All right, next it says, write a function to calculate n factorial. Everybody know what n factorial is? Like, what's 5 factorial? 5 times 4 times 3 times 2 times 1. And 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 1. All right, so we want to write a function that does that. All right, so I got to come up here and make my prototype. What kind of function will that be? Will it return anything? Yes. What kind of thing will it return? An integer, because factorials are always integers. So it's going to return an integer. What do we want to name it? Factorial. Does it take any inputs? Yes. it takes an int, and what variable name would we like to give that? Num, number, val. I'll go with number, I guess. Semicolon. Okay. Come down here. Int. Factorial. Oops, no semicolon there. No semicolon there. Okay, so this function is going to, we're going to send it a number, like we'll send it the number 5, and it will return 5 factorial. How do we make the computer figure out 5 factorial? A for loop. Okay. So 4. 4. Int count starts at 1. When does count end? So it keeps running as long as count is less than or equal to number. That's when we want it to stop. Yeah, we're going to go 1 times 2 times 3 times 4. And then we want count plus plus. Then what happens inside of our loop? You're telling me I need a variable? What kind of variable? Integer? Total tells me we're adding stuff. I would use product. Product means we're multiplying stuff. Fussy, I know. Would total work? Yes, it would work. But total to me says you're adding stuff. Here we're multiplying stuff. All right, so what do we want inside our loop here? Product times equals count. Oh, total product times equals count. All right. Finally, well, I'm not going to see out product. I'm going to return it. I'm going to send that number back to wherever it called. So I don't want to print it here. I'm going to return it. So after it computes it, I return it. Product. The cursor was in the way, I couldn't see. That's my story, and I'm sticking with it. Return product. That's almost correct. That will not quite work. I don't want to return inside the loop. Yeah, what would that do if I put that inside the loop?
It would return it every single time.
Worse.
Oh, it'll only return.
What it would do here is it would come into the loop, count would be 1, it would do product times equals count, it would return product, which means it jumps out of the function altogether, and it's done. So you do not want the return there because it's only going to multiply by 1, which isn't going to do anything, and send it back to the main or back to the call. The mistake we made back at the beginning, we have to initialize product. We have to start it out with a number so that when we go to use it here, product times equals count, that will do it. All right, let's test it. Let's see, I'm going to need a variable here, int value, I suppose. we'll print the header. And then cout. Enter a positive integer. And I will compute its factorial. All right, so right now, this program is going to create a variable called value. It's going to run the header. It's going to run the header function, so it's going to print our little header here. And then it's going to ask, enter a value. We'll type in the value, and then what do we want to have happen? We want to run the factorial function for value, and I suppose we want it to print, right? So I think I could just go cout, call the factorial function, value. Let's try it. I don't know 7 factorial off the top of my head, so I'm going to go with 5. It says the answer is 120. It's 5 times 4 times 3 times 2 times 1 equal to 120. Maybe.
Well, yeah.
5 times 4 is 20 times 3 is 60.
So it is the right answer. So 5 factorial is 120. Give us the right answer. Want to try it with 7?
That'll,
7 factorial is 5040.
I think 77 is too much for an int, right? I think, no, because, no, that's too much.
77 factorial is
Zero.
0.
That's because int is long enough, right?
It overloads it, yeah.
So you can do long. I still don't think it'd be long enough. It'd be over quicker than long sorry numbers.
Yeah, 77 factorial is too big for it to do. All right, so there's a very simple function that inputs one value and outputs another value. All right, the next one says, write a program to determine the final grade in this class. You will ask the user for lab grade, which counts 25% of the total grade, project grade, 10% of your total grade, quiz average, 10% of your grade, 3 test scores, and final exam grade. What's that? Oh, yeah, okay, we'll go back to C. This one wanted us to make lots of functions. All right, we'll go back to C first, I guess. Write a function to read values from a file and sum them. Okay, so we've done that many, many times, haven't we? We've read in values and found their average or found their total or found their sum. What's the difference between doing it in a program or doing it in a function, I mean? What's that? Okay. What else is different about it? Can't change the read position, but we never could. Well, actually, we can. We don't. There are ways to do that. So, I guess I don't want this. Actually, I'm going to take out all of this. Let's just start with a new thing. Kill it all. Void name. All right, so we want a function that is going to read values from a file, and it's going to sum them. Now, it doesn't say, does that function return the sum back to the main? Or does it print the sum in the function itself? It doesn't tell us, does it? Which do we want it to do? It could do both. It could print the value and return it. All right, so we'll do both. All right. If it's going to return a value, then what kind of value is it going to return? Float. Okay. What do we want to call the function? Sum. What inputs go to this function? Hello? But are they going to be, am I the user going to send the values to the function? No. Where's it going to find the values? It's going to read them from a file. So what values are we sending into the function? We're not sending anything into this function. This function is going to go to the file. It's going to read the values from the file. It's going to add them all up, and it's going to kick it back to the main. What are we putting into this function? We're not putting anything into it. So it's empty. So that can happen. Sometimes you can have functions that give you outputs, but they don't have any inputs. And this is a good example. All right, so let's go down here and write our function. Float. I suppose before I write my function, I should create a input stream, shouldn't I? Well, I guess I need a if stream. What do we want to call it? Read. Use this one on the desktop again. Let's change it though, put some integers in there. I know, I'll fix those in a minute, but thank you. All right, so there it is. Okay, so in our function, now notice how things are located here. You want your function prototype to be here. Your function prototype should be here before your void main. After your function prototype should come your read stream or your output stream before the void main. If I put this command in here, then this read will only work in the void main. It won't work in functions. Okay? So you want to make sure you put your read stream and your write streams before the void main, after the function prototypes. So function prototypes come first, read write strings come next, void main comes third, and that will allow you to read and write within the functions themselves. If you don't put them in that order, it won't work correctly. Make sure you put them in that order. All right, down here, inside our function, what does our function do? What do we need inside our function? We're going to need a while loop to read to the end. Okay, what else do we need? Do I need any variables? Yeah, I think I need a variable here, don't I? Float, total, initialize it at 0. And then I think I need another variable just to read in the values. We'll call that value, I guess. Read the first value. What do I do after I read the first value? While not read dot fail, set of parentheses, Need another one. And then inside my while loop, I update my total. Total plus equals value.
When you read it, can we initialize one outside of it?
Say that again.
You have to the value of the initialize value outside. Oh, you did.
I did. Yeah, so I read the first one. If it didn't fail, it comes in here and it adds, and then it reads the next one, tests to see if it fails, add, read the next one, test to see if it fails. Okay, so that's going to add them all up. It's going to read them all. It's going to add them all up. After I've read them all and added them all up, what do? Well, we decided we were going to print here, didn't we? All right, so we would see out the total is total. And then we decided we were going to return that value because maybe in our program we're going to need that total for something else. Don't know what. What do we want in our void main?
Does that mean that total is defined?
Total, right now, the variable total is only defined inside this function. If I try to use the variable total here, it will not work unless I define it here. Typically, we wouldn't do that, though. Typically, we wouldn't have a variable called total here and a variable called total there. We try not to use the same variable names. But yeah, variables are in very different places here. Any variable that I create here will only be in the void main and will not be in any function. Any variable I create here in the function is only in this function. It's not in the void main and it's not in any other function that I might create. So you've got like separate little programs, really, with their own variables. All right, so I can write sum, parentheses, semicolon. That I'm not sure about. My guess is yes. If it's in a class and you call the class in at the beginning, and you call the class in before the void main, my guess would be it would exist everywhere. But I'm not sure about that. I'm a little worried about this because when this gets done, it's going to try to return something. And it seems as though if it's going to return something, we should store it. I don't know if this is going to work or not. It seems as though we should print it or store it or do something with it. I could, but I'm already printing it here. So I think I'd rather just store it. So I'm going to go float. Total value. All right, so if I run this program right now, what this should do is it should create a float variable called total value. It should run this sum function, which adds them all up. It should print the total is, and then it should return that to here. So total value should have the value of total in it. All right. Total is 13. Is that the right answer? Yeah, because in the file we put 1, 2, 3, and 7. 1, 2, 3, and 7. Yeah, it goes up. Is that up to 13? All right, so there's a nice example of a function which has an output but no inputs, and a good example of making sure you have this in the right position so that you can use it with inside your functions. Questions about that? All right, now the big one. Write a program to determine the final grade in this class. You will ask the user for lab grade, which counts 25%, project grade 10%, so on and so forth. Make a function to calculate the test average. Make a function to calculate final average. Make a function to determine letter grade. Make a function to output lab grade, project grade, quiz average, test average, final exam score, final average, and letter grade. So we're being told make 1, 2, 3, 4 functions. All right. So again, I'm going to start all over here. Do I need this? Do I want to write my answer to the screen, or do I want to write it to a file? Screen? All right, so I'm not going to need that at all. Okay. So we need to create 4 functions. The first function is going to make a function to calculate the test average. I'm not going to need. Yeah, I'm not going to need either of these. Might as well take them both out. Okay. So we need a function to calculate test average. Will that function give us an output? Yes. What kind of output will it give us? An average, which is probably going to be decimals in it when you divide by 3, probably, so it's a float. I'll call it test av. Will this function have any inputs? Yes. What kind of inputs will it have? 3 test scores. Are those integers or floats? Like ints. I think your test scores are ints. So I'm going to use ints. Test 1. Int. Test 2. Int. Test 3. So there's the prototype. And now we'll write the actual function. All right, well, how do we find the test average? Return 100. That would be convenient. That would be convenient if everybody's test average was 100. It would make my grading so much easier. Fortunately, that's not quite correct. What do we want to return? Test 1 plus test 2 plus test 3 divided by 3? Yep. Almost. No, I haven't written anything in my void main yet. I'm just writing my function that will find the average of my 3 test scores. I need a decimal because I made these ints. Probably should have listened to Chris and just made them floats. It would have made my life easier. I wouldn't have had this mistake, but I didn't. I made them ints. But my return should be a float, so I need to make that be a decimal right there.
You could just be mean and just
I could be mean and truncate. That's true, but I don't.
you're a nice person.
I'm a nice guy, sort of.
Best answer.
All right, so there's our first function. That one was pretty simple. Second function. Make a function to calculate the final average. Final average, that'll again be a float, won't it? Final av. Okay. What do I need to send into final av for it to be able to compute your final average? So I need to send in all those values. All right, but I can't call it test av because test av is a function name.
Test average.
Test average, that's a float. Test average, float, Lab Av, float, what is it? Project Av, Proj Av. Any others? Float, Quiz Av, and then one more. Final exam, is that a float or an int? Probably an int. Int. Right. Go ahead.
Our test average and test abs are both the same.
Well, yes and no.
We're going to input the test average and the test average when we run that function, right?
Right, so what's going to happen, test av is the function that will calculate our test average for us. This test average here will be the number that this function gave us. So we're going to take this function, we're going to give it our 3 test scores. It's going to compute our test average. We will take that number and plug it into this number right here, test average. So they are different things. This one's the function that creates the number that we use there. All right. Okay, so this function is going to calculate our final average. So we got to use all the numbers here. It says, well, we're going to return, right? We're going to return 25% of your grade is lab average. So I should take lab av and multiply it by 0.25. Plus, then it says projects count for 10% of your grade. So proj av times 0.10. Quiz average is 10%, so quiz av times 0.1. Quiz av, better? Thank you. And let's see, your 3 test scores, their average is 30%, so that's going to be plus, what did we call that one, test average? Times 30%. And then finally, your final exam. We called that one final. Times 2.5. It worried me that I had it in blue for a while.
Yeah, and in blue, you didn't think about it as well.
Sure wonder if final was like
Yeah, that's scaring me. It's making me think that final is probably a command already in C++ and I wrote it in blue. So I probably don't want to use that word for a variable name. That's probably a bad idea. So I'm going to change this to final score just to be safe. Right, it might be. I'm not sure what it is. But just to be safe, when you see that happen, when you see something come up in blue, it's probably best to avoid using that as a variable name. It probably means something else. Okay, so I think that will do it. I think that will compute our grade, our final average. Make a function to determine letter grade. All right. We did that already, didn't we? Well, we got to do a new one. All right, so this is going to compute our letter grade. Is this going to return anything? Yeah, what's it going to return? A character. It's going to return a letter grade. All right, so this is a char type function. Call it letter grade. Do we need to send it anything? We need to send it the number grade of our total average, don't we? So we need to send it,
But we take it from the float file.
right, so we're going to run this function. It's going to compute the number that we need, and we're going to take that number and we're going to send it to this function, and then we'll use that function to get our letter grade. All right, so what do we want to call this? I'll call it total av. Total average. All right, in the interest of time, I'm not going to write this whole function. We'll just write part of it, but you'll get the idea of what this is. So what will this function do? If total av is greater than or equal to 90, then what kind of grade do you get? An A. So we'll just return the A. Oops. Character. I'll put a little quotes. Else, if total av is greater than or equal to 80, return B. So on and so forth. What else would I need in this? If it's greater than or equal to 70, return a C. If it's greater than or equal to 60, return a D. Else. I'm going to be really cruel.
Yeah.
So either you get an A, you get a B, or you get an F. There's no C's and D's anymore in this course.
Well, you put that after the if statement, so it's going to...
Notice I put that after all the if statements. So what's going to happen? What's going to happen if my final average is, say, a 92?
It'll say A and F.
Just return A.
It'll return A, and then it doesn't do anything else that's in this. So return is kind of a cool thing. Return kind of works like a break inside a function. Because when you do a return, it sends it back, and it doesn't do anything else that's in the rest of the function. So return is kind of a cool statement. You can use it like a break to say, I figured out everything I wanted, I'm done with this function, go back to the beginning. So if my average is 90, it's going to return an A, and it won't do anything below that. Same thing down here. If my average is an 86, it's going to return a B, and it's done. If my average is not greater than 90 and not greater than 80, it's going to return an F. That's all it's going to do. Okay, last one. Make a function to output letter grade, project grade, quiz average, test average, final exam score, final average, and letter grade. So this is a function that's just going to output a bunch of stuff. It's going to print either to the screen or to a file. We decided to go to the screen. So if all this is going to print, what kind of thing is it going to return? Nothing, so it's a void. Print stuff. Print SOOF. What do we need to send it? Pretty much everything, because it says it's going to print the lab grade. So I need to send it float. What did we call that before? Lab av. So I shouldn't use the same variable name. So I'll call it lab average. Float. Project grade. So I guess I'll call that project average. Float. We need to send it quiz average. I'm going to get lazy and call that QAV. I'm running out of time here. We need to send it the test average. PAV. We need to send it final exam score. That's an int. Final score. Nope, final, I don't know what to call it. F-score. Final score. Final average. That's a float. Final average. And finally, the letter grade. That's a character. Char. Right, so what's this going to do?
What we just typed is saying, here's the things we need to use. But how does the computer know that the lab average refers to the lab average that came out of the program?
When we call the function, we will need to make sure that we put things in the right order. So when we call the function, we're going to send it a whole bunch of numbers. We need to make sure that when we call it, that the first number we tell it to use is the lab average. And we need to make sure that the second number we tell it to use is the project average. So on and so forth. So when we call this function, we'll need to make sure we put our numbers in the right order. It'll be up to us to tell the computer which one is which. All right. So this function isn't going to do much. It's going to see out lab average, see out, project average. Yeah, you don't like that? All right. What you're saying is put end lines in. Oops. A project. I don't have a project average. So on and so forth, correct?
Yeah.
Just about out of time. All right. Well, I don't think we're going to quite have time to finish this today. Notice at this point, we don't have anything at all in our void main. All we've done so far is we've built all the functions that we need. What are we going to put in our void main?
Just the function.
We have to tell the person to input all the stuff. And once we input all the stuff, then we'll call our functions. All right, so we will pick up here. Now Thursday,